to solve systems of equations with two variables only. All right. There's two ways to do this algebraically, and then obviously graphing will always work too. Okay, but graphing can be a pain unless you're going to use one of the electronic graphers, which I would still recommend. Graphing linear things though, like two variables, that's not so bad. Okay, so these are going to be linear only. We're not going to have any x squares or anything like that this time. Okay, we'll save those for another day. So to solve a system algebraically by substitution, you need to pick an equation and solve for a variable. Okay. So let's do an example at the same time that we're writing this down. Okay, so you're going to pick an equation and solve for a variable. Here's the first example. Now I'll tell you this, we're going to do this example twice. All right, two ways. We're going to do it with substitution and with elimination. It's not going to take super long either way. All right. So 2x plus y equals 4. And 2x minus y equals -1. You need to choose an equation and get a variable alone. I don't care which equation, except there are some things that make this a little bit easier. Which of these equations would you choose, using maybe intuition here, which one would you choose to get something alone in? The top one? Which variable would you get by itself? Y. Okay. So what's your reasoning? It's not negative, and it already has, it does not have a number in front other than 1. Okay, so if you choose this top equation and solve for y, you get y equals 4 minus 2x, or -2x plus 4, take your pick. So you choose an equation and solve for a variable. Probably look for +1 coefficients in some of your variables. Okay, to help you. You don't have to have that, but it turns out a little bit nicer. You don't have fractions, etc., going into substitution. After you pick an equation and solve for a variable, you will substitute or plug that expression in to the other equation for that variable. Yep. Oh. Thank you. Did you get it? Okay. All right, here we go. So substitute in for that variable in the other equation. Now parentheses are going to be really important in substitution. Okay, and this is a good example of why parentheses are really important. So if I take this thing right here and I want to plug that in, the whole thing, for y, I'm probably going to want some parentheses because y is subtracted. You want to make sure to subtract all of what y was equal to. So that's going to give you 2x minus parentheses 4 minus 2x equals -1. All right. Now we need to solve for x. Remember, your goal is always to get one equation with one variable when you're solving algebraically. So how can we get x alone?
You can start by distributing the negative.
Distribute the negative. So 2x minus 4 plus 2x equals -1. For a second there, I thought the 2x's were going to cancel out. They don't, though. They combine to be 4x. If you forgot to distribute the negative, you'd be left without any x's. So -4 equals -1. Oh, no solution. Okay, that's not correct though for this problem. 4x minus 4 equals -1. Add the 4, so 4x equals 3. Divide by 4 and x equals 3/4. That's not my full solution. What do you need to do after you solve for that variable? Back substitute, yeah, plug it back in. Solve and and back substitute. That will get you an XY ordered pair for your answer. That's what you want. Okay, you always want your ordered pair when you have two variables. So I'll plug in 3/4. You can plug it into any equation that has X and Y in it. You can use one of the two originals if you want. You can also use this one right here. Doesn't matter. All right, let's use the one that has Y alone already. It'll save us a little bit of work. So that gives me Y equals 4 minus 2 times 3/4. You got to know your order of operations. You can't do 4 minus 2 before you multiply by 3/4. So 2 times 3/4, I can reduce the 2 and the 4. It'd be 2 on the bottom. So I really have 4 minus 3/2, which is 1.5. So 2.5. Very good. Is Y. All right. So your ordered pair, your solution is 3/4, which is 0.75, and 2.5. If you'd rather use fractions, you can do that instead. I don't like putting fractions and decimals in the same ordered pair. To me, it doesn't look right. You can do it, though. Not wrong. Does that make sense? Okay, that's a pretty basic example, solving by substitution. Let's do this a different way, okay? So we're going to do the same example, and then we're going to talk about how they compare and why you might want both of these in your tool belt so that you can use them when it's easier to use them, all right? To solve by elimination, it's also called linear combinations, maybe in Algebra 2. It depends on what Algebra 2 language your teacher used. Okay, so if you have, I'm going to rewrite the system. 2x plus y equals 4, and 2x minus y equals -1. For elimination, you want to get opposite numbers in front of one of the types of variables. Okay, and when I say opposite numbers, let's see, can anyone give me an example of opposite numbers? 2 and -2, yeah. Okay, so opposite leading coefficients. So opposite numbers in front of a variable in each equation. So like 2 and -2. For example, 2 and -2. Okay, 2x and -2x. Here we go. Do we have opposite numbers in front of any of our variables?
No. Y and negative y.
Well, y and -y, 1y and -1y. So we're ready to move on. Sometimes that's done for you. Maybe that's a little bit of a hint as to which method will be easier for a problem. Okay, so opposite numbers in front of one of your variables. After you get opposite numbers, you're going to add the equations together. Okay, or you can subtract them. If you get opposite numbers, you're going to add. If you have the same number, just subtract. But you have to be sure to subtract the entire second equation. Okay, so we're going to say add, because I told you to get opposite numbers. Add the equations together. Now that should give you one equation with one variable. If it doesn't, you did something wrong. Okay, so let's come over here. We're ready to add the equations together. When I add the equations together, I'm going to get 4x. Those cancel out. All right, that'll happen if you get the opposite numbers. Equals 4 minus 1, which is 3. Or 4 plus -1. Then divide by 4 to solve for x. Yeah, I have one equation with one variable. I only have x's in my equation. All right, so you're going to divide by 4 and get x equals 3/4. Yeah, I had that a minute ago. This is where elimination is going to get a little more difficult. How do you find the y value?
You make the other one not.
You could. You can go back to the drawing board and go 2x minus 2x and subtract this whole second equation, or change all the signs and then add. You can still plug it in. Doesn't matter what equation, as long as it has an x and a y in it. Okay, so I might plug it into the top one because it has a positive y. All right, so if I plug this in for x to the top equation, I'm going to get 2 times 3/4 plus y equals 4. So 2 times 3/4 gives me 3/2, which is 1.5. Plus y equals 4. Subtract 1.5 and y equals 2.5. So my ordered pair is 3/4, which is 0.75, 2.5.
I think that's the one that they taught. That's the one I remember the most.
Yeah, and either one of these is possible. It's not like you have to do one of them all the time. You can do either one for every problem. However, there are advantages to each method in certain types of situations. So, when would you want to use elimination? Let's work with the one we just did. When would you want to use that one over substitution?
There's no like.
If there is like variables, or if there are unlike variables and they're all on the same side, then elimination is some people's preference also. Okay? So, but elimination is easiest if you already have opposite, or if you have the same numbers, it's still relatively quick. Okay? If you have opposite numbers in front of one of your variables, or even the same number in front of one of your variables, you should probably use elimination. When do you want to use substitution?
Substitution is easiest when one of the variables is already by itself, like
Yeah.
how y is already by itself.
Yeah, when you already have an equation with a variable alone, okay, or close to it. Like if you had 2y equals something, then you could just divide by 2. So if a variable is already almost alone, go ahead and use substitution. By the way, substitution is going to be the one that will always work. Remember I said that on Tuesday, okay? So if something always works, you definitely want to keep that in your math nerd bag of tricks, all right? No matter how many variables, no matter what kind of variables or what's done to the variables, substitution will work. That's a good thing, okay?
I remember something like I remember like doing the elimination kind of, and I remember like I thought if they were different and like nothing was matching, and like the numbers were completely like random.
Yeah.
Like we'd have to figure out, we'd have, like multiply the top and the bottom by like 2 different numbers to get they make equal. But
You have a
to
good
multiply
memory.
by 2 different numbers.
So let's look at one like that. Can we do that? Okay.
I feel like this is no common sense, but common sense.
Well, it's not as difficult as some things we've done might seem. Okay, so let's try this. Let's go with that one. In fact, let me give you a decimal one, because that'll answer some questions at the same time. Okay, 0.03x plus 0.04y equals 0.75. All right, and 0.02x plus 0.06y equals 0.90. You want to put the 0 on the end of it. We're going 2 decimal places for all of them. All right, let's solve this system. What Austin was talking about a second ago is that if you have different numbers in front of all of your variables, then maybe you can find a least common multiple or a common multiple. They don't even have to be the least common one for all of them, okay, or for for two of the variables at the same time. So let's do something initially and then we'll work on that. First of all, the fact that this is all decimals sometimes gives people a headache. Okay, so what I would do is I would find the decimal with the most places and I would multiply by 10 to that power. So for this one, multiply everything in the top equation by 100 and multiply everything in the bottom equation by 100. Okay, because what that will do is it'll move your decimal points 2 places to the right. We're good. Unless you have questions. Do you have questions?
No, but I have a question of what I have.
Okay.
Is it on my agenda?
It will be. Is that when you're leaving?
Yeah.
Enjoy your day. I'm recording class, so you can see that. Yeah.
We love you.
Okay. So let's multiply this entire top equation by 100. That'll bump all the decimal places 2 places to the right, which will give me all whole numbers, which is so much nicer than decimals for most people. Okay, if I multiply the top equation by 100, I'm going to get 3x plus 4y equals 75. Be careful, make sure that you move both decimal points 2 places, and because of that, I'm going to erase the 0, because I think it'll be a little bit better. Okay, I think you'll throw in something that might confuse people. See how we still have 2 places past the decimal? I'm still going to multiply by 100. I don't have anything that's 3 places past the decimal. Okay, you do not have to multiply the top equation and bottom equations by the same thing, but you do have to multiply everything in one equation by the same number. So if I multiply this by 100, I have to multiply everything in that equation by 100. All right, so let's multiply the bottom one by 100 as well. You don't always have to multiply top and bottom by the same thing. All right. There we go. Move 2 places to the right, and I get 2x. What did I put underneath here? We all right? Okay. 2x plus 6y equals, what do you get when you multiply 100 times 0.9? 90. You still have to move 2 places to the right, even though you only have 1 digit past the decimal place. All right. Now I have all whole numbers. It doesn't look as bad. All right. How do you, but we need to get opposite numbers in front of one of our variables. Let's see. How can we, opposite numbers? We don't have anything that's the same right now. We have 2 and 3 and 4 and 6. 2 and 3 in front of x and 4 and 6 in front of y. If your variables are not already lined up, like the x is in line, the y is in line, you'll want to get them that way. Okay, so rearrange. And the equal signs have to be lined up. What did you say, Tina? That'll work. That'll work. It doesn't matter which one gets the negative. Okay, the first one. And it doesn't matter whether you choose to eliminate x or eliminate y if the numbers don't share any factor. Like 4 and 6 share a factor of 2, so I could multiply the top one by 3 and the bottom one by 2. Okay. However, let's go with what you were saying. You said top one multiplied by -2 and bottom one by 3. Okay, so if I multiply the entire top equation by -2, I'm going to get -6x. All right, I'm going to have to watch the video to make sure I'm not off the screen. -6x. And then if I take -2 times +4y, I'm going to get what?
-8y.
Yeah, so I need to put -8y, and that equals -2 times 75, which is -150. All right. The bottom one you're choosing to multiply by 3. So take 3 times 2, which gives me +6x. That's good because that's kind of what you were aiming for. And then 3 times 6 gives me 18, and it's still positive, 18y. And 3 times 90 is going to give me 270. Now I'm ready to add my equations together, okay, because I have opposite numbers in front of x. So -6x and +6x cancel out. 0x. If you don't get 0x or 0y, then you haven't finished the elimination process. You need one equation with one variable. Negative 8y and positive 18y gives me 10y. And that equals 430, no, this is negative 150. 120. So if I divide both sides by 10, y will equal 12. To find x, what will I do? Plug it back in, and it doesn't matter where. Okay, any equation with x and y in it, which one do you want to use? The 3x plus 4y equals 75? Okay, so here we go. Three x plus 4y equals 75. That's the one that some of you chose, so we'll do that one. Here we go. 3 times x, which we don't know x, so I don't really need to do this, plus 4 times 12 equals 75. All right, 4 times 12 is 48. So 3x plus 48 equals 75. Subtract 48 from both sides. Okay, so 3x equals 27. Divide by 3.
9.
And x equals 9. Absolutely. Okay, your answer is the ordered pair 9, 12. It does not matter which one you find first. It matters which one is x and which one is y.
Wouldn't it be 0.9 and 0.13?
Because even though it's like, even though you multiply by 100, it's still like the same ratio, so
That's right.
9 and 12.
That's a good way to put it. It's still the same ratio. All right. Hey guys, if you come up with all of your variables canceling out in elimination, your answer could be no solution, or it could be all real numbers. Okay? We'll talk about those more tomorrow.